www.sulfurrecovery.com/webinar is our landing page for all our previous webinars. We've also digested or cut up some of the webinars into a more digestible format, such as if you only had 10 minutes, you can watch on a specific topic. So I encourage everybody to share that link with their fellow colleagues in order for us to spread the word of some of the best practices out in our industry. Once again, thank you everybody for attending, and thank you for your time. I really appreciate it. So once again, we do have a fairly short program with respect to talking about sulfur wash. What we're doing today is a basic overview of what a sulfur wash is. We'll do some introductions with respect to SRE, myself, and of course, what is sulfur wash. Identifying the problem with respect to what type of problems, what ways we can identify the problems which you may use sulfur wash. Then we'll go ahead, talk about the steps of the sulfur wash. Quickly, we'll do the recommended follow-up questions that you should be figuring out, and then we'll wrap things up and do the Q&A. This session will definitely be useful if, for example, you've never heard of a sulfur wash. If you're an operator that needs a refresher on how to conduct this procedure, or you're just looking for some best practices or some ideas on with respect to this procedure. As always, if you need specific help with your particular situation, obviously we're doing just an overview, so there might be some details that don't apply, or there might be some specific questions that you have. Feel free to ask them during the session. Otherwise, feel free to email me, call me, and I'll make sure to get you the right advice. And the last note, I was talking about our webinar series, our link to our website with our previous webinars. This session, we're assuming that you do have the knowledge, basic understandings of the SRU, of the modified Klaus process. You do understand how the chemistry, the thermodynamics, and all of that happen within the Klaus process. So if you are unfamiliar, for any of those real novice or real beginners, make sure you go to our website, www.sulfurrecovery.com/webinar, and get the info that you need to brush up. So on with our presentation, introductions. So who are we as SRE? We are a company that's been around since 1998. We've been helping out operators, engineers. We've been helping out EPC companies, regulators, in order to help them get the most performance, a better understanding of the capabilities of sulfur recovery and amine units. We're definitely concerned with the reliability of the units, we're concerned with the performance of the units, and we definitely want to protect the environment, protect individuals, and at the end of the day, protect your bottom line as well. Since 1998, we've grown, we've spread into different areas, and we've gained more services. I like to distill all of the things that we do and all of the ways that we help our clients into 3 different categories: our testing services, our simulation services, our learning services. What we have is, our bread and butter was the SRU on-site sampling and analysis. We give analysis on site. That has moved forward to commissioning, startup, and shutdown assistance, which really does apply with our sulfur wash today as a lead up to what may cause you to use a sulfur wash. And then we do have also testing products. Our testing and on-site sampling has moved out of just the sulfur plant to the amine unit and to onwards into other units within a refinery or gas plant. We also do a lot of simulation services. We are fully capable of doing dynamic SRU simulations through VMG Sim Dynamics. One of the very few companies who are able to offer that service. And we also do design consultations. And over the years, almost 20 years now of experience that we have, and we've turned all of that experience into our learning services. So we do on-site bespoke training, tailor exactly what type of training that you need for your operators, for your engineers. We go ahead and we get that down to exactly your objectives, and we train you only on that, providing pretty good value, I believe. A little bit about myself. I've been with SRE for quite some time, coming up to close to 10 years now. I would have to say that my most exciting destination with SRE has had to be Thailand. It's interesting to see a refinery like overrun by monkeys, and I'm not talking about the operators. There's actually monkeys everywhere. For those of you who haven't been to a tropical climate or a tropical country like that, it's pretty interesting to see these monkeys just running around all over the place, acting like they own the refinery. And that really did bring a smile to my face. And finally, what is a sulfur wash? For those of you who may not know, primarily it's a technique that we use to remove soot from Klaus catalysts. We'll talk a little bit more about how the soot is formed a little later on. We want to remove the soot because we want to get to a normal pressure drop. The soot formation, as you can probably deduce, if you don't already know, leads to higher pressure drops, stops you from actually using the SRU at all. Operate the effective converter below the sulfur dew point temperature results in the accumulation of sulfur on the catalyst. And that's basically what we're doing. We're going to get sulfur to accumulate on the catalyst and get rid of that soot. And it's important to remember that theoretically the technique should not affect your overall performance. So therefore, doing this procedure should result in a zero net effect on catalyst activity and overall recovery efficiency. Identifying the problem. So when would you use the sulfur wash procedure? We could have looked at this presentation in two different ways. We could have said, well, how to deal with soot, and we could have done that with respect to talking about soot formation and dealing with the overall topic on soot. But instead I decided what we should do is focus on the sulfur wash itself and take it from that point of view. Yes, it's true that the most common problem that you use sulfur wash or the sulfur wash procedure is for tackling this soot accumulation, the fine soot on top of a downstream catalyst. But we have made suggestions to clients who have come to us and said, well, I have these catalyst fines that are accumulating, I have this channeling that's happening, I have this deactivation that's occurring, but I don't know what it is that I could possibly do in order to try to remedy the situation without having to shut down. I've in the past mentioned they could try to do a sulfur wash in order to remedy these problems other than the soot. Now, I should indicate that even though the potential is there that the wash can remedy, I have no testimonials myself with respect to them utilizing the procedure or any successful stories of it being used in those situations. But if you want, you can ask me questions later on. I can feel free to share you my thoughts and theories on how sulfur wash can solve these problems. But if you are one of those people who have used it to solve one of these other problems, please do feel free to contact me and share with me my story your story. So back to the soot. How do you form it? Well, it's improper burn of fuel gas, whether it be refinery or natural gas. Improper burn of maybe say a slug of methanol comes into the main burner, changes its stoichiometry, how much air that you need. You can have soot formation there. Also, there's possibility of hydrocarbon carryover from the upstream amine or sour water units, which can result in soot formation. Depending on the sources that you check out, there's some people that say, okay, well, hydrocarbon carryover because upstream units usually operate well. It's not common. Usually it's more the fuel gas burn or the burn that would happen within, say, direct fire reheater. And although that's correct that the likelihood is very minimal for hydrocarbon carryover, it doesn't mean that it's impossible. The little examples that I'm using in the webinar today actually are from our client of ours who did have hydrocarbon carryover from an upstream unit. So it's important to note that it definitely is possible. And when you're thinking of, okay, well, what can contribute to me, to myself burning my hydrocarbon at a level that's 70% or lower deficient, which will result in soot formation. That's the kind of idea, where is that hydrocarbon going to come from? So methanol, carryover, or drastic change in composition. Maybe your fuel gas is something that normally is 60% hydrogen, and all of a sudden now you're switching to something that's 6% methane. Things to keep in mind when you're trying to figure out, okay, where is the soot coming from? This is a slide that I used in our cost savings webinar that happened last month. Definitely a great webinar. I got a lot of positive feedback. So if you haven't seen it or caught up on it, definitely check out our website and check it out. With respect to all the costs associated with the SRU, during that presentation, what I did is I broke it down into three main categories. You got your operating costs, relatively $1 sign. You have your maintenance costs like catalyst, equipment replacement, performance evaluations, $2 signs. And then you've got those emergency costs. You got penalties from your environmental regulator for SO2 emissions. You got to troubleshoot a problem that you're having. So you're spending money with regards to getting third parties to come in at the last minute in order to troubleshoot an issue. Or the regulator comes down hard on you and saying, you know what, every quarter you got to do this third-party verification to say that you're meeting your recovery efficiency or your emission licenses. And those are the $3 sign costs. So if we were to say, let's look at these three categories with respect to the soot formation and using the sulfur wash, what would be operating costs associated with soot formation if you were to leave it untreated? So if you're not going to do anything and you're going to have the soot continuously be formed, what are the risks? So on the operating side, what you have is you have that increase of front end pressure. That's going to happen. Now, majority of the cases when we're dealing with soot formation and wanting to use the sulfur wash, majority of the time it's happening instantaneously. With respect to over a week or a month or a year's time, it happens fairly quickly. The example that we're going to be using today, you'll see that it happened fairly quickly and within a matter of hours. But if it were to happen slowly, over time, you're getting that increase in front end pressure. And also that increase in front end pressure results in a reduced SRU throughput, which means a reduced plant throughput if you only have one unit handling your sour acid gas or your sour water acid gas. So that's money you're losing right there through reduced plant operations. Further, if we go $2 signs up, you have some maintenance costs that are going to be associated with not correcting the soot formation problem. You'll have your condensers possibly plugging up. You've got your catalyst that has the layer of soot happening. If it's fine soot, yes, we'll be able to use a sulfur wash, but are you 100% sure that this soot is actually not a heavy hydrocarbon soot that might be something that's gunky, might be something that cannot be removed through a sulfur wash? Also, you run the risk of, over time, that soot forming a crust. And once that crust hardens, then there's no turning back. At that point in time, you have to do the emergency stuff. And when you get to the emergency side, then you got emergency shutdown, you got costs associated with that. You've got production loss because you're shutting down. As that increase front end pressure occurs, you also run the risk of blowing it through your seal legs, which therefore you run the risk of exposing your employees and the environment and the area to H2S and SO2, especially if that's coming out of your first condenser. That can be 5 to 7% H2S or SO2 going into the atmosphere right there at ground level. So a lot of costs, and it could quickly build up when you have this issue, and you got to keep in mind all the externalities when you're trying to evaluate how much is this costing me. Continuing on with identifying the problems, how do we identify soot formation? There's various ways. The most obvious and quite obvious one is to monitor your DCS screen. Should you have a significant amount of soot formation, the front end pressure is going to rise fairly quickly. We'd have a little graph right here. We have front end pressure in PSI, and we noticed that as time went on, 1, 2, 3, by the third to fourth hour, boom, pressure went up from 3 PSI up to 9 PSI on this chart on the right. Another indicator that I usually find fairly indicative of something going on or some change happening is the combustion airflow rate, and that's the total combustion air needed for the acid gas. Acid gas is going to the front end. With respect to the caveat there is that your ADA is properly calibrated, properly and well maintained. If that is the case, and you're fairly certain that it's measuring properly the H2S and SO2 numbers, over time you'll notice that the total combustion air, if your acid gas composition is changing, you'll notice that that combustion air will slightly change as well. This is great way to notice something on the DCS, and another item to monitor. One other item is to remember that also it's not just the front end that is having to have the potential of creating soot. Like I mentioned, if you have a direct fire reheater, those are other sources, and therefore you might not have soot coming onto your first catalytic converter. You might have soot coming onto your second or third, should you have DFRs at the second and third stage. The obvious and tried and tested and true method of determining plugging is to do a pressure survey. Go ahead, and it's important to go ahead and do a survey that's before and after every piece of equipment, every unit op. I know this is a lot to ask for older SRUs. Typically, there's not enough sample points available in order to do that. And so therefore you're second guessing yourself, okay, is it that our condenser is plugged up, or is it because our converter has soot on it? And because you don't have that resolution due to inadequate sample points, it's kind of tough. So maybe something you want to keep in mind is that, well, if we were really serious about identifying soot formation, maybe we need to go ahead in the next shutdown, install those sample points in locations that we don't have currently. And that's another important point for any SRU designers who may be attending today's session. You want to make sure that you're building SRUs with those sample points upstream and downstream of the unit op, of the piece of equipment, such that you can do an evaluation of that unit without having to second guess what's happening during a long pipe run, or having two pieces of equipment tied together because of the sample points. Number 3 is discussion with operations. You know, when we do our SRU performance evaluations, that's number one thing in order to gain information for myself, in order to understand what's happening with the SRU, if there's any problems that have been going on. The guys on the front lines definitely understand what's been going on, and they know the little nuances. Some slight thing might have changed and may not have been caught on the DCS, but you know, something like a rundown running a bit off colored or not running the way it used to. It's little pieces of information like that that can trigger, okay, maybe there is a bigger problem. Maybe we do have soot formation going on. And always number 4, SRE services. What I like about our performance evaluations is that we provide with you the 100% stoichiometric burn for the compositional analysis of your feed streams, whether that be the acid gas or whether that be your refinery or natural gas going to the DFRs or the front end if you're co-firing. So we'll provide you with those numbers, and obviously from that you can go ahead and excuse me, you can go ahead and evaluate if your flow meters are running properly. Talking about flow meters, our performance evaluation reports also go ahead and tell you if your flow meters are properly calibrated. A lot of examples of those individuals who've had soot formation problems, main reason is, if it wasn't because of a slug coming over, was because the fuel gas flow meter was improperly calibrated, and so instead of doing 10-to-1, they're doing 7-to-1, and they had no idea. And as such, it sooted up the downstream converter. So the SRU performance evaluation is definitely a great way, a lot of valuable information in order to not only know if your catalyst is fully active, but a lot of things to point out in order to identify if you have any soot formation. So that's about it on identifying the problem. Let's go into the meat of the presentation, which is steps for a sulfur wash. And really, it's fairly simple. I break it down into 3 steps. I know there's other individuals who will break it down to 5 or 7 steps, going point by point. But overall, I like to believe that it's fairly simple. You're disabling the upstream reheater to the converter that you'd like to do the sulfur wash in. Converter number 1 means that you're disabling reheater number 1. Then you're allowing some time to go by, let the sulfur accumulate. And then you do the heat soak in order to liberate that accumulated sulfur into the downstream condenser. Now let's go into a little bit more detail with each of these 3 steps. So when you're disabling the upstream reheater, what you're doing is you want to be able to operate the downstream converter at a subdew point temperature. That's basically what it is. You want to make sure as well that you're reducing the converter bed temperature gradually. Converters do have refractory lining, so if you're operating, say, the first converter at upwards of 600 Fahrenheit, obviously you would want to slowly decrease that temperature such that you don't shock your refractory. You'll notice that we have a graph here on the right. The x-axis is in hours, 0 being the time that we're starting the sulfur wash. And this is the converter inlet temperature, so the thermocouple downstream of the reheater. This is the process gas going to the first converter in this example that we've got from our client. And we see here that they, within the hour, they were able to, while following some guidelines, reduce their temperature and get ready for step number 2. Step number 2, allow the sulfur to accumulate on the catalyst. So we expect that the reheater will probably be offline for a period of 7 to 20 hours. What you want to do ideally throughout that time, while you're doing this accumulation of sulfur, you want to be monitoring the pressure drop across the converter. You can also do that another way by monitoring the front end pressure. You want to be also continuing to do this either until one of 2 things, either until your normal pressure differential, maybe a pound, 0.5 pounds differential across the converter, is obtained, or when you come to the point of maximum sulfur loading, which we'll talk about a little bit more later. And like I said, it really depends on how long, really depends on, the location of the converter. You would expect, of course, the first converter to have more sulfur production versus the third converter, which would have minimal sulfur production just because of the loading. The first and second converter are already doing the work of converting that H2S and SO2 to elemental sulfur, so it'll take longer for the third converter to actually accumulate the amount of sulfur needed in order to wash out the formed soot. And once we're back to normal, we are happy with the pressure differential, our front end pressure as well. Then we can restart the heater and gradually heat back the converter. We want to aim for temperature approximately about 50 degrees above your normal operating temperature in order to do the heat soak. So we're noticing here on the graph on the right that we've overshot our normal converter inlet temperature for a period of time. And this is to heat up the Klaus catalyst, do that heat soak, get all that sulfur accumulation off the catalyst. We want to regenerate the catalyst. In doing so, we want to make sure that every single pore that had any sulfur plugging it up or accumulated on it gets liberated and collected in the downstream condenser. So if I'm on site and I'm helping a client out do the heat soak, I will go out and normally check the rundowns in order to ensure, check the flow consistently. You could do a couple of things. You could do a visual check, take a tin can and start measuring, and you can keep track of how the flow is increasing and then eventually how it's decreasing. And then when it steadies out, then obviously you know that the rundown is back to normal. Or you could do a time lapse. Here we did it, our client did it for about 5-10 hours. Or you could just run it 24 to 36 hours. You have a couple of options there. Here's an example of the temperature profile that went through with the converter that went through the sulfur wash. We do have in the light blue our converter inlet temperature, and in between the yellow, red, green, and dark blue, we have the top, middle, bottom, and outlet thermocouples. So we're noticing from the time that we started to the time that we ended, how the bed responded. Obviously, the top thermocouples are going to cool down more than the bottom temperatures. But it's good to see in a little example like this. At least you have an idea of what to expect when you're looking at your DCS screen the next time you do the sulfur wash. Likewise, we have another slide here indicating the front end pressure from the beginning all the way with as well the reheater. So in blue, we have our front end pressure, which utilizes the y-axis on the left, the primary. And we have in red the valve opening. We have a hot oil reheater here. So the valve opening to the hot oil reheater utilizing the secondary axis. You can notice very well that we have on the front end the sharp pressure rise at the beginning. Then we can see here when we're turning off the reheater to go into our sulfur wash. And then we notice the sharp rise here in order to do the heat soak. And as we're performing the heat soak, obviously we're getting rid of that sulfur. There's a slight increase of the front end pressure while that's happening. Again, it's really good to have these graphs in front of you in order to illustrate what you will see once you do your own sulfur wash. Finally, with respect to steps of a sulfur wash, there's some really important considerations that you need to keep in mind. One is, how much liquid sulfur can my catalyst hold? It's a question you can definitely ask us. With respect to your specific situation, we'll be able to give you an answer with that. Catalyst vendor is definitely another one that you can ask that question. Another thing to keep in mind, we're loading up the converter that wasn't designed initially to operate in the sub-dew point level. We're not talking about a sulfurine unit here, where the catalyst bed has been designed to hold liquid sulfur within it over a course of time. We're dealing with a converter that was designed to operate at a specific temperature. So you need to understand how good your catalyst support is, the supporting grating and the support balls, in order to understand, okay, am I going to do any damage while performing the sulfur wash? Number 3 is always important, probably so important, I probably should have put it as number one. You got to keep on checking your emission monitoring system. Doing the sulfur wash does not mean that, oh, okay, I'm accumulating sulfur, so therefore I won't have anything happening on my downstream or to my emissions. I should have less emissions. Yes, that's true, but you have to keep in mind that even though you're focusing on a particular problem, you do also have to keep in mind of the overall scenario. The SRU is supposed to be recovering my sulfur. I do have emission guidelines that I need to follow, so you have to keep in mind that I need to keep on checking my SEMS, my emissions monitoring system while things are going on. Temperature change within the converter, I mentioned it a bit earlier, the refractory. So is the temperature change drastic enough to damage that? You want to keep in mind that there is refractory there, and adjust your temperature change to a point that is gradual enough to protect that refractory. And number 5, obviously you got soot, you're washing it out of the converter, you're washing it off the catalyst. Where is it going to end up? More than likely it's going to end up in your rundown. More than likely it's going to end up in your sulfur pit. So think about what precautions you might want to take in order to minimize off-spec product. And there's only a few more slides here, so we'll quickly get through that and then get to the Q&A. So recommended follow-up. It's really important that as an operator of an SRU or as somebody that's providing the recommendations that you do your due diligence and answer these questions once you've gone through the exercise. Number 1, did the sulfur wash fully rectify my problem? You need to verify, okay, yeah, so I do have my pressure transmitter on my front end saying that we're at the same level as before. Are we 100% sure of that? You know, is there something else that I can do to ensure that the problem that I thought that I had was solved? As well as the secondary question, was I correct in identifying the problem? We do sometimes the sulfur wash, and like I said, maybe you might do the sulfur wash for something other than soot formation, but you need to really be sure that you identify the correct problem, and as well that the solution or the procedure that you followed rectified it. So much times what we experience talking to our clients is that when they got this soot formation, it's because they're starting up. They've already gone through a 2-week, what was supposed to be a 2-week shutdown, which turned into a 3-week, 4-week shutdown. So there's lots of stress in the environment on site in order to get back to normal production. There's lots of money being lost every day that the plant's not running. So there's lots of stress in order to get this pressure drop sorted and get things back to normal. So when the dust is settled and you've done the sulfur wash, at least to a point where you've gotten more of a handle of the situation and stresses are somewhat relieved, it's important to go back, take the time, spend the 5 minutes and answer these questions. And do make sure that you rectify the problem. Number 2, has the incident affected my SRU in any way? Theoretically, like we said at the beginning, theoretically, there shouldn't be any change. The procedure itself should be non-invasive, you could say, to the catalyst activity, to your recovery efficiency. But the incident itself may have done something to the catalyst. The incident itself may have done something to your equipment. Now you need to ask yourself, how do I check to make sure those things are not occurring right now, that I'm 100% safe coming out of this procedure, coming out of this incident. Number 3, and always the most important, but always the one that's forgotten and left to the side, what was the cost of this incident? What overall did we lose in order to get ourselves out of it? Definitely a sulfur wash is something it's due primarily to an unplanned event. So it's important that you take the time to look at what happened and to look at what steps, what lessons learned in order to avoid it from happening in the future. And I always try to remind my clients to ensure that you take into account all the externalities. You got to take into account the overtime. You've got to take into account the added stress. There is a cost associated with that. And also you got to take the time, if people were removed from other projects. You know, one prime example, recently there was an oil spill here in Alberta. And given the oil and gas turndown, obviously there's not as many people in head offices as there used to be 2-3 years ago. So because of the oil spill, they decided to put everybody onto solving the problem. Why is the oil spill happening? What happened? Let's analyze the data. All the projects that were going on at the time were put on hold in order to troubleshoot this issue. All of them. And there's a cost associated with that. And sometimes we kind of tend to forget that including those costs in my projection when I'm talking to my manager about how much this affected our bottom line, it's important to realize that taking people off of another project, there's a cost associated with that. So the final comment there is just make sure you're doing your due diligence. And as a final wrap up, I always like to leave our viewers with 3 notes about what I would like you to remember. With respect to SRE, 3 things that I'd like you to remember is that we are on-site problem solvers. We come on site and we'll solve your issue. If you got soot formation or you think you have soot formation, we'll come on site, we'll do the tests, and we'll do the necessary due diligence in order to verify that that is the actual issue that you're having. There's multiple ways that we can do that, and we can also go ahead and perform the sulfur wash on your behalf to get that problem solved. With respect to the SRU, amine units, anything in your refinery, we'll try our best in order to be able to solve your problems, always. We're here to answer all of your questions. Like I said, my email, WhatsApp, BBM, call me, anything. We're always here to answer your questions. If you have anything, do let us know. And quite frankly, how much money can we save you? When you start adding up the cost, we recall that slide that I showed you earlier. If you left that soot formation unchallenged, if you just let it be, what are the risks? And quite easily with H2S, SO2 exposure, getting people sick to the infirmary, the costs can add up fairly quickly. So it's important to keep in mind how much costing we can save you. And with that, I'd like to thank you all again for your time and your attendance. Thank you for taking the time to be with us today. We surely appreciate it. Like I said, once we're done today, the presentation, this is being recorded. It'll be uploaded to our website, www.sulfurrecovery.com/webinar. I do hope that you found the material today useful. Like I said, the Q&A board has been open this whole time. If you have any questions, thoughts, comments, feel free to use it in order to send me a message. I'll try to answer them right now. If you're a bit shy, you can send me an email. I can answer it later. If you do need to use a sulfur washer in the future, definitely write down my contact information and keep it on file. You never know. We'll definitely be happy to help you through that, even if it's over the phone. We do that a lot and help our clients through their problems without being on site sometimes. A little bit of pro bono work. With that, let me open up the floor. We have one question that came in. We have the temperature change step guidelines to best protect refractory. Definitely a great question. Like I said, I'm going to be answering this verbally. Typically, we're talking about a step change of 50 degrees Celsius per hour, maximum 100 degrees Celsius. You want to definitely check with your refractory vendor with respect to specifics to yours, but typically it's around that 50 Celsius, 100 degrees Fahrenheit per hour in order to protect that. Great question. We have another question came in here from your testing. Do you see definite change in catalyst activity after the wash? Yeah, it's a tricky question because I'll say that in my experience of performing sulfur washes is yes and no. Referring back to my original comments earlier where I was talking about soot formation. If you recall, I was talking about you have the fine soot that lays on top and then you have the potential for it to turn into a cake. So what ends up happening is if you are in a situation, for example, where you had some of the catalysts covered by this cake stuff, and then you had some of the catalysts still had the fine soot, the sulfur wash would have cleared the soot off of the fine soot, but wouldn't have done much to alleviate the caked on stuff. And as such, once we get through the sulfur wash, what we do with our clients when we're on site is we will do the performance evaluation right away, so such that we can verify the catalyst activity afterwards and verify their overall recovery efficiency. And then we would compare that to the last time we did those numbers for them. And in that scenario, I've seen where the catalyst activity has decreased because now you've got some portions that are plugged up because of this cake stuff. So do I see a definite change? The answer to that question is yes, you'll see a change. If the incident has done something to the catalyst, you will see a change. And that's why we always recommend, once you do a sulfur wash, you'll want to make sure that, what was that question? Number one, you want to make sure that it solved your problems. And number two, you want to make sure that the incident itself didn't affect your SRU. Great question. Great question. Hope that helps out a lot of people who may have been thinking about that. And another question here, my supervisor wanted me to ask how much a shutdown and startup support costs. Estimate is fine. Right, and definitely that's true once you're doing the cost analysis of what the incident overall has affected the bottom line. Obviously, you want to do a cost comparison in order to verify what steps could we have taken in order to not have this situation happen. And that's where SRE startup and shutdown support comes in, because we'll ensure that there is no soot formation at all during startup or shutdown, by not just relying on flow meters to have the correct burn stoichiometry, but actually using our portable equipment and our on-site equipment in order to verify. We do actually a double, triple verification steps in order to make sure that there's absolutely no soot occurring. So in order to estimate, typically, let's say we're on site for a startup, which typically takes a shorter amount of time than a shutdown. I would say that ballpark for just the on-site work, this would be without mobilization, without flights and subsistence and all that stuff, you're looking at around $10,000. So to give you an idea of a cost, you're looking at $10,000. As a super ballpark. Definitely it's really dependent on how much on-site work you'd like in terms of duration and stuff like that. So, but to give everybody a ballpark with respect to being able to do that cost analysis, you could definitely email me for a more specific to your situation, but the ballpark's about 10,000. Great question. Great question. Really thinking outside the box there with that one. Next question that came in, what simulator does SRE use? Use this to help me better understand how long a wash would take in my bed. Yeah, you could definitely be able to use the simulation. What we use is VMG Sim in-house. VMG Sim also does include all our 20 years of sulfur plant data through VMG SRE correlations. Definitely the best, in my opinion, the best predictive tool. That's a little shout out to our VMG partners. Yeah, that's what we use. VMG Sim is what we use in-house. And with respect to how long the wash would take, yeah, you can use that. And like I said, it's really specific to your situation. If you wanted a more concrete answer on the duration, definitely feel free to contact me afterwards and we could talk a little bit more about that. Here we go. We have, is it very common to use this procedure? I would say yes, it is. Obviously, nobody needs to report that they've used this procedure. I'm only familiar with those clients who we are in constant contact with who end up in this situation. Like I was saying, those who are proactive and do sulfur recovery, sorry, let me broadcast this so everybody can see it. I'll start over here. So the question is it very common to use this procedure? And with respect to our clients who have been in a situation where they've had to use this, yes, it is common for them to use it. It has been done in the past quite some time. There's quite a few people who have done papers on this particular topic, sharing their experiences. So relatively speaking, it is a common procedure. That being said, it's an unlikely scenario to end up in, right? So those of our clients who conduct regular performance evaluations, and I would refer you back to our cost savings in order to see exactly, there's an example there of our clients who don't do regular performance evaluations and the costs that they incur because of that, and then those who do constant performance evaluations. So those who do constant performance evaluations on an annual basis, they have the information at hand before there's an incident, meaning they realize ahead of time, before their next shutdown or next startup, that direct fired reheater 3 fuel gas flow meter is 30% off the actual number. So therefore, they've had us come out, do the performance evaluation. We've done a full health check of the whole unit. And part of that health check, we told them, hey, when you look at the numbers, you got to recalibrate the flow meters of this DFR. Either it's the air that's off or it's the fuel gas that's off, but clearly there's something wrong and you need to fix it. So what they'll do is they'll know that prior to going into the next turnaround, they'll go ahead and fix that problem, and then on the startup they won't have an issue. Whereas if you didn't do the annual performance eval, you would go into the shutdown blind, not knowing that these flow meters were, or that particular flow meter was not properly calibrated for whatever reason. And during startup, you'll just notice that the soot is being formed, or you'll just notice that my front end pressure is increasing, and not really know where it's occurring or what's happening or why it's happening, right? So it's a two-part answer to your question. The first part, for those who are in the situation, yes, it's common to use it in order to try to remedy. But the fact is that majority of people don't end up in the situation to begin with because they do the necessary preventative maintenance in order to ensure that it's not happening. And then the other scenario, like we said at the beginning, is if there's a trouble with respect to an upstream unit or with respect to a slug that came into a gas plant or something like that. I hope that answered your question. Definitely appreciative of all the questions coming in. They're great questions. And like I said, we're always here to answer your questions. If you have any more, feel free to keep my contact information and send me your questions as they come up in the future.